Even though you're probably very familiar with this from GCSE material, it's worth a couple of slides just talking about the properties of decay. And in this case, I've also put radiation. So for example, I'm sure you've seen the nice pictures before of how these different types of radiation, different types of decay behave in a magnetic field. So here's a magnetic field where we got the positives on this side, the negatives on that side. Alpha particles, of course, are positive, 2+, so therefore they deviate towards the negative side. Okay, and their mass, of course, is 4, and that will become important in a second, because when we think of beta particles, well, beta particles are, of course, negatively charged, so they go towards the positives. Okay, and because they're lighter, it's easier for the magnetic field to pull them in, so therefore they have much more of an attraction and a deviation to the magnetic field, because it's not as tough to push them out of their path as it is the big fat alpha particles. And then of course you have positron, which is exactly the same as an electron, except it's positively charged. So we see a positron has the same attraction for the field, the same path as the beta particles, the electron, just going in the opposite direction. For completeness sake, even though it's very boring, gamma rays just pass straight through because they're radiation, they're not affected by the magnetic field. However, it's also worth noting that while we haven't touched upon it yet, a very important particle that is produced by nuclear processes is, of course, the neutron. And neutrons in a magnetic field would pass straight through because they have a charge of 0. So the behavior in a magnetic field of alpha particles, of beta particles / electrons, and positrons. It's also worth noting and reminding you about the penetrating power of these various things. Alpha particles, which I'll represent here, 2 protons and 2 neutrons stuck together nicely. But essentially, if alpha particles are being beamed at you, just stick a piece of paper out and it will all be absorbed in the paper. Alpha particles not strong enough to penetrate even paper. Beta particles, a little bit stronger. They have no problem getting through paper, but they're stopped by pretty much any solid that's more than a couple of millimeters thick. Now, these days, it seems like aluminium is the material that's chosen to show, hey, beta particles get absorbed by aluminium. They can't get through those, but they can get through paper. Back in my day, it was wood. Pretty much any solid that's more than a couple of millimeters thick will do it. But I talk about wood rather than aluminium, kind of boring aluminium. Then, of course, gamma rays, very, very, very penetrating. They blast through paper, they blast through wood. It takes big lead shielding to stop those. And I know you've seen that before, but just worth mentioning as we're talking about alpha and beta particles. Positron, of course, will be exactly the same penetration effect as beta particles. When we think of the potential damage, and I'm not going to dwell in this set of videos about the damage and the benefits of various nuclear things, I will put in a separate set of movies on those later on. But it is worth noting, of course, that all of these are forms of ionizing radiation. In other words, you have alpha, beta, or gamma blasting through a cell, well, then they will ionize whatever they come in touch with. They'll knock off electrons, they'll turn things into nasty reactive free radicals. You don't really want your cells and so forth ionized by radiation. However, alpha particles, of course, they can't penetrate your skin, so therefore the big danger with alpha particles comes if you ingest, or of course the positive benefits of alpha particles come from ingesting. Beta particles, pretty much the same thing. You have to ingest them because their penetrating power is not great. You're not just going to pass through the skin and so forth. But if you're exposed to a significant amount of beta radiation, you can get some external burns. Gamma, of course, they're really, really nasty things. They're extremely dangerous to cells. This is beneficial because it can be used for treatment for cancer, but of course it is extremely dangerous. If you're exposed inadvertently to gamma radiation, you'll get some nasty burns, you'll get some DNA attack and so forth. So all of them nasty. You don't want to mess around with it too much, but increasing dramatically as you go from alpha to beta to gamma.